Yeah, so P and P. And in the other direction, it won't read. Yeah, I know it's really hard to see what I'm doing, but I promise you it doesn't read in the other direction. Oh, actually, just out of interest, it's PMP, and it's got a gain of 441. So these connections are arranged so that whether you get emitter base collector or emitter collector base, you can still plug it in. Clever. Don't use that very often. But if you had some unknown, if you say you bought a bag of transistors, you used to get surplus computer parts and things, and it was quite interesting to see if you could do them. Is this going to collect? This is collector base emitter, and it's NPN. So if I put that in, no, it's that way around. Collector base emitter. Supposed to be NPN. Yeah, it's NPN. It's emitter base collector. Yeah, it's not reading. I think it's making a connection actually. Oh well, stick it in the circuit, see what happens. Okay, well here's a whole oscilloscope and it's only got 2 transistors. (7905). It's literally the light from my window that's illuminating that. It's like black writing on a black background, it's that hard to see. That's the price of cheap components. They don't waste any money on painting them. And this is U4. Which goes here. And this is definitely the last one. This is U5. Can't really check these with a meter because your meter would have to put out a lot more than 5 volts for it to work, and different regulators, different voltages. So U5, and it does say in the instructions, caution, packages are similar, they're identical, apart from the writing on them, and the internals being completely different. Righty-ho. So if you imagine the carpenter's old saying, measure twice, cut once, well, our equivalent in electronics is check twice, solder once. So see, splatting solder all over this multi-way connector. I remember the good old days when desolder braid had enough flux on it that it would absolutely suck the solder clean out of the holes, but in these days of being environmentally conscious, they don't really give you much flux anymore, because it's corrosive and harmful to the environment. And sadly, electronics does consume large amounts of hazardous chemicals, which is why you should always recycle your equipment as much as possible. We're still recording. Wow, yeah. 2 trimmer capacitors, you can't put those in the wrong way round. There is a slight favoritism. They are designed to only go one way round. It does make a tiny difference to the tuning of them, because there's an outside capacitor and an inside capacitor, and they can be affected by you waving your hands too near. So they try and isolate them. Now you can just stay there while I solder you down your nose. The eagle-eyed among you will have noticed there that I just spread the wires apart so that they would stay in. It didn't work on that one. No, it did not work on that one. Sorry, I'm drifting off the edge of the bench in an attempt to see what I'm doing. You've got a better view than I have, I promise you. And voila. So they're in the right way around, they're set level. So another component ticked off. The big coil, L2. This doesn't matter which way around it goes. Come on, it's here somewhere. How can such a huge component be missing? There's now a significant number of holes that aren't going to have components in. They've marked it positive and negative, but it doesn't matter with a coil. 1 millihenry rated at 0.5 amps, so there's a good chance this is generating the negative power supply. Rather than having a transformer, and just use the back EMF off a coil being switched on and off. There are 6 100 microfarad capacitors, and I'll wager they're the only holes left. There are only 6 capacitors left. So it's 1921, and this does matter. Electrolytic capacitors have a white marking for the negative pin, a longer wire for the positive pin. It's pretty hard to get it wrong. That's 19 and 21, 22 and 24. $25 is one of them. $26 is one of them. Not too bad on low voltage circuits like this, but if you did put them in the wrong way around, and the high voltage circuits would tend to explode them. If not straight away, after a period of time. They do not perform well either in reverse. Sometimes they'll appear as a short circuit. Okay, and that's my last one of those. Shocking state that iron was in then. I must say, for a cheap iron, it's given sterling service for quite a few years now. I would like a better one though. The temperature controlled ones are vastly superior because this is spending most of its time being too hot, and then when you try and solder something large, it just cools down straight away. Whereas with a temperature controlled one, you get the benefit of it always being at the right temperature. 6 capacitors in, the jack in next. That can only go in one way, that's for certain. Oh my word, they've supplied a jack that won't fit. Or have they? Ah, it goes in J10. Good thing I checked. Okay. That's why it won't fit, it doesn't go in that place. So with these, it's good. You can start the heat off at one end and then draw the iron across to the other end and reheat it. Or, on one like that, you can get the iron all the way along in one go. You will pick up different soldering techniques as you go. But a generous amount of solder never does any harm on a load-bearing socket. That's J10. There's a 3-pin and a 4-pin header. Well, it says there is. These headers are optional. And they provided this long one, so I think they want you to cut your own. So we'll have a 3-pin one and a 4-pin one. I can be reckless because I have a drawer full of these for the Arduino. So the 3P one is for the UART, should you wish to suck data out of the oscilloscope at some point. And that would be a nice little project. And as I said when I started this channel, I'd like all my projects to interconnect with each other to a degree. So this is 3.3 volts clock, data out and ground. So that again is potentially an I2C bus or something that we can connect to. Better to put them in now, and then you're not hunting around for a connector when you want to use it. Okay, just noticed some jumpers here that you could put a blob of solder across if you needed to. Then the next one is the pin header female. Sure it is. Now I realise I've got solder in some of these pins, so I'm going to have to heat them from this side, gently. It's coming down nicely. Not seeing a pin there. So either the pin is in the middle oh, that's bad. I think the pins have sunk into the socket. The pins have indeed sunk back in. That one didn't, but this one has. That could be a problem. behold the solder sucker. It's a bit brutal for this, but needs must. The general idea is to get some good solder on there, heat it, then throw that over, and place the plunger. Behold, that's one clear. Right, should have done that first really. And what I'll do is, this pin that's fragile, I'll put to the other end. Yeah, so a pin that's fragile, that one doesn't come through. Trying to do this without putting any weight on it. Right. Let's borrow this piece of foam. Now I'm checking I can still see all the pins. Right, so I guess I have to be careful now not to overheat these. It is clearly not a very good quality socket, but then it's only ever meant to be plugged into once. Okay. and again it's the getting in contact with the circuit board underneath and the pin. The bit that you're actually soldering on the board is called the land as opposed to the C. But yeah, getting that contact with the land and the pin, and then you can get really good heat transfer, and then you can be in and out as fast as possible. So they made a connector with gold flash contacts. It's actually self-destruct. Okie dokie, not much to go now. So the switches. One, two, three. So all the switches are three-way, and they'll all only go in one way. Oh, and they'll sit in as well by the look of it. There's enough friction there to hold them. So the ones that are the casing, you need to give them a chance to come up to temperature. Once you get that initial flow of solder, you can always add a bit more. There we go. Now this is a bit dainty. So again, spreading the heating effect out by doing one side first and then the other. As we've already seen, some of these components, the plastic is not of high quality. And then the last one is the biggest of them all. And it does say that this will require longer to heat up. This is the BNC connector. This is our input for the whole oscilloscope. The board is quite hot where I've just soldered those. It's going to get even hotter when I solder this. So I'm going to do the pin at the back because that's going to take less time. And I'll sweat some solder into it. Again, because it's the sort of thing that may have physical force applied to it. Now this is gently warming up. It can take quite a while, just have to be patient. It is going, it's just taking its time. And same here. That should be fine. That will be hot now. So that's your basic assembly. Okay, so for the test signal we have to connect a wire through the 2 pins on J20. Shit, that is hot. J2. Oh, there's a blob of solder there. There's a blob of solder there. It's always good just to check there's nothing is spidered across several junctions, connections. And that there's no dry joints. Okay. And what they want me to do now is to connect 2 sides of J2 together. So what I'll do is get a component leg from a surplus resistor, bend it double, leave one end longer than the other, then I can push it in. Ow, that flipping thing is hot. So all it's going to do is get one in here, and turn the other one round and get the other one in there. It doesn't matter whether it goes through the board out particularly. I could stop burning myself. And then solder it properly. So that's the test loop. So now we can get our probe onto it. We need a 9-volt power supply. So I'm going to finish there for today. There's another jumper we have to jump together to test it, and that will push the test signal back into the scope, and that's JP3. Whatever that is, that's JP2, JP1. And then you've got these feet as well. So I'd imagine the feet go onto here, that's to support it in the case. And the other jumpers are underneath. Oh, these connectors here don't do anything, they're put to support this display. So we can insert display. Preferably by putting it in the right holes. And then these pins here, and they're just sort of hovering over those. Aha! There's something they didn't tell me. There's 2 connectors left over. If you solder them into here, they will be used to support the LCD display. Right, just noticed something shorting out.